This is questions 17, 19, 20, 24, 26, 31 and 32 from exercise 9.2 in Project Maths 2. We have to solve for x in each of these equations. So we'll start with question 17, where we have 5 to the power of 2x is equal to 5 to the 10. Since the bases are the same, that would mean that in this situation the powers must be the same in order for the equation to work. So we can now say that 2x is equal to 10. And if 2x is equal to 10, that means that x is going to be equal to 5, like that. So that's that for question 17. Let's take a look at question 19, where we have the same bases again. We have 3 to the power of 3x minus 1 is equal to 3 to the power of 5, which means that we can say that 3x minus 1 is equal to 5. And if we go about solving that, we get 3x equals 5 plus 1. So 3x is equal to 6, which means x has to be equal to 2. So that's our value for x in question 19. In question 20, we don't have a number that's already at the same basis, so we're going to rearrange something. We can't do anything to change 2, but we can do something to 8. 8 is 2 to the power of 3. So we could say that 2 to the x is equal to 2 to the 3, which means that x is equal to 3, like that. Now for question 24, we have 4 to the power of x minus 1 is equal to 32. Now 32 can't be written as 4 to the power of something, so we're going to have to rearrange both of the bases in this. 4 itself can be rewritten as 2 squared, so we have 2 squared all to the power of x minus 1, and 32 can be written as 2 to the power of 5. On the left we have the power to a power rule, so that's going to be 2 to the power of 2 times x minus 1, which is equal to 2 to the 5, which means that the powers are the same. So if we multiply these brackets, we're going to get 2x minus 2, and that's equal to 5, which means that 2x is equal to 5 plus 2. So 2x is equal to 7, and that means that x is going to be equal to 7 over 2, like that. Alright, let's take a look at question 26. In 26, we have 2 to the power of 2x minus 2 is equal to 1 over 16. 2 to the 2x minus 2 can't have anything done to change it. But 16 is 2 to the 4. So that's equal to 1 over 2 to the power of 4. And if we bring that up using our negative power rule, we get 2 to the 2x minus 2 is equal to 2 to the power of minus 4, which means 2x minus 2 is equal to minus 4. And if we go about solving that, we get 2x equals minus 4 plus 2. So 2x equals to minus 2. So x is going to be equal to minus 1, like that. Let's look at 31. Now for 31, we're going to have to sort out what we have on the left here, which is going to be our division rule to start with. So we're going to have 3 to the power of, and it's going to be 3x minus 1 minus x plus 1. In other words, the power on the top minus the entire power on the bottom. And that's going to be equal to 9. But 9 itself can be rewritten as 3 to the power 2. So now if we tidy up what we have on top, we're going to have 3 to the power of 3x minus 1 minus x minus 1 is equal to 3 to the 2. So we've got the same base and different powers, so the powers must be equal. So we can now say that 3x minus 1 minus x minus 1 is equal to 2. We're going to tidy this up, and we're going to get 2x minus 2 is equal to 2, which means that 2x is equal to 2 plus 2. So 2x is equal to 4, which means x must be equal to 2 in this case. And then for our last one here, we're going to have to rewrite our 25. So our fraction is going to become 5 to the power of 4x minus 1 all over 5 to the power 2, and that's going to be equal to 5 to the power of 1. because 5 on its own is just 5 to the power of 1. We can apply our division rule with the fraction. So we get 5 to the power of 4x minus 1 minus 2. That's equal to 5 to the power of 1. So now our powers are equal to each other. So we get 4x minus 1 minus 2 equals 1. So we're going to move all of our numbers over to the right and keep our letters on the left. So we get 4x equals to 1 plus 1 plus 2. So 4x is equal to 4, which means x is equal to 1 in this case. And that is that.